Ionic compounds are not considered molecules because they are made of many positive and negative ions held together in a repeating lattice by electrostatic attraction, not by discrete neutral units with covalent bonds. Think of a molecule like a small toy made of parts snapped together that always stay together in the same grouping, such as a water molecule with 2 hydrogens and 1 oxygen stuck together. An ionic compound is more like a giant checkerboard where each positive piece is surrounded by many negative pieces, and the pattern repeats over and over without a single small unit you can pick up. In ionic bonding, atoms transfer electrons, so one becomes positively charged and another becomes negatively charged, and the opposites attract in all directions, forming a solid network called a crystal lattice. Because the ions extend throughout the solid, there is not a finite group of atoms that behaves as one independent unit, the way a molecule does. When ionic solids dissolve in water or melt, the ions separate and move independently, showing that the compound is really a collection of ions rather than discrete molecules. A common mistake is calling formulas like sodium chloride a molecule because the formula looks like 2 atoms together, but that formula only represents the simplest ratio in the lattice rather than a bonded pair. Remember to think of it as a ratio, not a paired unit. Another misconception is assuming ionic bonds are weak because they separate in water. But actually, the electrostatic forces in the lattice can be very strong. The solution is to distinguish between strength in the solid state and behavior when dissolved or molten. Students also sometimes mix up covalent and ionic bonding by focusing only on electron transfer versus sharing without considering the resulting structure. Checking whether the solid forms a repeating lattice or distinct molecular units helps resolve this confusion. Visit www.gumballdegree.com to find more videos and resources on this topic.